So we're now going to take a look at the data type numpy array, and we're going to use it to plot functions. So let's first create some numpy arrays, and we basically always do this starting from a list. So we now create 2 lists here, and then I want to convert them to numpy arrays. To do this, I first need to import the package numpy, numerical Python, and then I can write, well, I can give it whatever name I want, but the important thing here is I write it like this. So now Python is taking my lists A and B and converting them to numpy arrays. This basically means that it keeps the contents here and then changes the data type, meaning that when I do stuff to these objects, the result can be different depending on how numpy arrays are supposed to act. So just to compare, if I take a list here multiplied by 2, Python will take the list and give it back to me twice. If I take the corresponding numpy array and multiply it by 2, then Python will multiply by 2 entry-wise. And this is a very good thing. You can also multiply 2 numpy arrays. You'll just multiply entry by entry. You can even divide, or you can take the power, or whatever you want. So now let's take a look at how to plot functions. And to plot functions, we first need an x-axis. So let's say x-axis here, or just x. And then there's a nice command called linspace. So now we're asking Python to create a bunch of points starting at 0, ending at 10, and in between, let's do, I don't know, 100 points. Of course, I'm getting no output here, but I can print my x. And well, perhaps it's easier if I do 2 points. So 2 points equally spaced starting from 0 and 10 would look like this. If I do 3, it will look like this. And if I do 11, it would look like this, okay? So now I have my x-axis. And how to get my y-axis? Well, let's define my function f of x up here. And let's just do y equals to x squared, return y. And now the beauty is here I can just write y equals to f of x. Because now, since x is a numpy array, he will interpret this as me wanting to apply f to every term separately. So we can do print y here. And here you can see I get 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, and so forth. And now if I want to plot, if I do import matplotlib pyplot as plt, down here I now do plt plot x comma y. End of story, I get my graph. So there's a bit of preamble here. Of course, if I'm just wanting to plot stuff, I don't need this. So this is enough code to plot this function using numpy. And of course, if I want the plot to be really good, I have to increase the number of points here. But yeah, that's how to plot functions using numpy arrays.